All right, welcome back to Mr. P Helps with Algebra 2. This is Unit 3, Topic 1, SLT number 2, and we are once again finishing up this SLT with a second video. We are doing a very similar warm-up here to begin with. Playground merry-go-round has a radius of 9 feet, a circle that's center is 11 feet from a climbing wall. Find the distance at each given point away from the wall. Okay, so A is easy. It's 17 because it's the same distance away from the wall as the center. G would be also the same, but it's not one of the choices here that we have to do. D is 17 plus 9, which makes 26 because this is 17 away, and we know this is 9 more away. J can easily be found because 17 minus 9 is 8. And B. Okay, so to find B, we're actually going to have to use some trigonometry. So we have to figure out the height of this triangle. So in that triangle, we can just simply use the formula since we've been doing it. So it's always radius times sine of theta. Theta is the degrees. Now 1, 2, 3, 4, 5, 6. So it looks like there's 12. 360 divided by 12. Turn this on. 360 divided by 12 gives us 30 degrees per rotation. So that's sine of 30 plus the center height, which was 17. 9 times sine of 30 and parenthesis plus 17. Whoops, delete that. Enter, and you get 21.5. Now, of course, F would be the same, but we're not asked to find that. E is going to be the same as C, so I can find the height of C. It's going to be the same thing, only it's going to be 60 degrees. So it's going to be radius of 9, so everything's going to stay the same. So it's going to be 9 times sine of 60 degrees plus the center height of 17, and that gives us 24.79. Let's just round that to 24.8 for the time being. H is going to be the same distance below 17, so 17 minus that difference right there, which, okay, so I guess I'm going to have to figure it out again. So in this case, I didn't figure out, I kind of skipped, I went straight to this. So I have to figure out what this height was right here, and then figure out what that is subtracted from 17 instead of added. So I'm going to clear this out. So 9 times sine of 30 gives us 4.5, but instead of adding 4.5, I'm going to do 17 minus 4.5, and that gives me 12.5 is the height of H, because H is the same height as L. So if this is 4.5, it's going to be 4.5 below as well. If it takes 60 seconds to do one complete rotation, how long will it take for it to go its furthest point? So its furthest point, well, if it takes 60 seconds to go all the way around, then you know it takes 30 seconds to go halfway around. And it takes half of that time, which is 15. 15, 30, 45, 60. So it takes 15 seconds to be the furthest away from the wall. All right, so answer the following questions about the merry-go-round from the warm-up. I'm going to move myself again. I like to be up top. Oh, there we go. How far away from the wall would you be after a 75-degree rotation? So we just, I guess we're still using the same numbers from the warm-up. So let's see, 17 feet away, 9 feet, 17 and 9. So this was 17 and this was 9. 75-degree rotation. Okay, so I know it's radius times sine of 75 plus the center height. 9 times sine of 75 and parenthesis, then add the 17, and that gives me an answer of 25.7, give or take, round to the nearest tenth. What other degree rotation would also be the same distance away? Well, if I go 75 degrees, that's about right here. That'd be the same as this reference angle. So if this is 180 degrees, and I take away 75, then I get a 105-degree rotation. Because this 75 and this is also 75 degrees, and these two must be the same heights. That's why it's 180 minus 75. Recall, it takes 60 seconds for a complete one rotation. How can you come up with a model to represent that? Okay, so this is always the radius. This is always the degrees per second. Multiply the down in seconds, and then you add the center height. And okay, so that gets us to put it all together. I'm actually going to stop there and let you do that one on your own. Thanks again for watching. Have a wonderful day. Please give it a like if it helped you learn how to find the center heights.